Okay, so I'm going to talk to you about the terrestrial analog studies and in particular about the VERITAS Iceland field campaign. But first, a brief introduction about VERITAS. That is not changing slide. Okay, so the VERITAS mission, as you have heard already from Marta's and yours presentation, is a NASA discovery mission, and it will carry to Venus a radar system called VISAR, and the VEM instrument, which is the Venus emissivity mapper you talked about in the previous talk, is the same instrument that is going to fly on the ESA Envision mission. So it will map the surface composition using 6 surface bands that will cover the 5 spectral windows in the Venus atmosphere. And it will have as a main goal to map the global rock type. So I will, in the next slide, also mainly focus on them because it's the instrument I'm working with. But on VERITAS, there is also the radar instrument, and the VERITAS is going to perform also a gravity experiment. So the Iceland field campaign is named also as Expedition VERITAS. It has been performed last year, and we were on the field between July 13 and August 14. Here you can see in this picture the NASA and DLR team on the field. Of course, that's not the whole team. Many other people contributed and worked also remotely to organize the field campaign and are still working because we all have now all the data that we have to analyze and all the samples brought back from Iceland that we have to work with in the laboratory. And on the right of this slide, you can see a list of the involved DLR team, both on the field and remote. So the campaign was led from NASA JPL, by NASA JPL in a joint effort with the DLR and with local support from the University of Iceland. So while we were on the field, 2 geologists from the University of Iceland were following us and guiding us during the measurement on the field, while the DLR Institute from Oberpfaffenhofen, another town in Germany, was flying an airborne radar over the same site where we were taking measurement, because the idea was to compare short-scale radar measurement with high-scale radar measurement performed by the Dornier aircraft. So among the goals of the Iceland campaign, some more event-specific oriented goals were to study the spectral characteristic of different flows and to correlate the spectral characteristic that we see with radar and LiDAR data in order to improve the models of infrared eruption signatures. Also, we aim to create a catalog of as many as possible volcanic surface texture in order to use this as reference for when VERITAS will get to Venus. And another goal was to collect as many samples as possible to bring back to our lab and to measure them with the emissivity setup that we have in order to have data that we will then use for the calibration of data that we will get from Venus, from the Venus emissivity mapper. So these goals, together with other more radar-oriented specific goals, guided the choice of the field location in Iceland. And 2 sites have been selected. One is located in the middle of Iceland here in this region that you see here in the map. And another region is located more in the south of Iceland in the Reykjanes Peninsula that I'm sure most of you have heard about because the volcano is currently active. It's threatening the small town of Grindavik. So the first site is the Olbrand site, is the location of an active volcano. Volcano is called Aske volcano and is located in the central highlands of Iceland, as you have seen. And the main goal of the investigation performed here was to see how the different amounts of sediments then can change the radar interpretation. So going from moderate coverage of sediment to almost no coverage, and different lava structure and lava textures have been studied here in the field. And in this map here on the left, you can see the points where the team was, where we were to perform the measurements. The site number 2 was the Reykjanes Peninsula. And here the main goal was to study the 2021 lava field, the field generated from the eruption of the 2021, the one generated during the eruption 2022. And just almost few weeks before we went to Iceland, the volcano started erupting, to erupt again. A new caldera opened up, like the one that you see here in this picture. And so we could study the new lava flow, the 2023. Unfortunately, by the time we got to the field, the eruption was declared already off. We lost it for 2 days, but we could study this lava flow, and we could detect really points of the caldera that were still at really high temperature. So we actually got, while we were doing measurement, Venus temperature. And here you can see a picture produced by by Akin Domak from our department using Sentinel data. And it shows the eruption of 2023, of July 2023. So while we were on the field, as I said before, the DLR Dornier aircraft was flying over the same site and was taking radar data using both the S-band and the X-band. The S-band is the same band that has been used from the NASA Magellan data, while the X-band is the band which will be used from the VERITAS radar. And here the idea was to collect data to refine algorithms that will help us to see surface changes for when VERITAS will get to Venus. And actually the DLR guys on the aircraft were more lucky than us on the field, because they got to see live eruption, and they could measure the uplift of the floor, let's say due to the lava still flowing below between the 1st of August and the 7th of August. So what we did on the ground, we performed LiDAR measurement, and we sampled. The LiDAR measurement are a small-scale roughness measurement of. The idea was to select 5 meters per 5 meters patches, and then the GPS have been used to precisely line this measurement up with the airborne radar measurement. So the idea is that this patch of 5 meters per 5 meter correspond to a pixel in the radar data from the airborne measurements. And then samples have been collected for permittivity measurement. Permittivity is the measurement of how hard or easy it is for the electromagnetic waves to move through a rock. And this affects the measurement, like surface roughness. What we did as DLR team on the ground is that we brought a VEmulator, so an emulator of the Venus emissivity mapper of the instrument, in order to perform measurement on the field in the same bands that will be observed from the real VEM instrument, and to have this measurement to have a comparison with what we would get in the laboratory and what we will get when we get to Venus. So here you see a picture of Hassan on the field with the VEmulator. I will tell you a bit of history about the VEmulator. The idea started like more than a year ago when we went to our first field campaign in Volcano in Italy, and we wanted to perform Venus measurement to have a comparison with our laboratory data. And so 2 colleagues of our group, Saul Mazzadeli and Steven Garland, they started to build the VEmulator 1.0. It's more like a demonstrator of VEM, because it was composed by simple Raspberry camera with the removed infrared filters, and with 4 commercial filters that correspond to 4 filters of the VEM instrument. So we went to Volcano, we got the data, and we were quite happy, because when we compared the data with the laboratory data, we found a good match, and this pushed us to build the VEmulator 2.0, which has been built So by Stephen Garland from our department. The Vemulator is a bit more complex with respect to Vemulator 1.0 because it is composed by an infrared camera. It has all the 6 surface VEM filters that are mounted on a filter wheel mechanism, and it has an INGAS detector, which is the same detector that VEM will have. So here you can have a picture, you can look inside of the Vemulator. So you have the camera system here, you have the filter wheel here, and you have also a 3D printed baffle, which has been put there to avoid stray light. So any type of light that is not the light that we want, that comes from our field of view, but everything that comes from outside and we don't want in our data. So with the Vemulator, it has been possible to image and took data from different spots on Iceland and to image different textures of the lava field that we visited in all the VEM bands. And measurements have been performed in daylight, so catching both reflectance and emissivity, and in the nighttime, catching only emissivity. And here we got the help of a thermal infrared camera that really working on the lava field of 2023 in the Reykjanes Peninsula allowed us to spot areas at Venus temperature and then to image them with the Vemulator. So in the end, it was a really successful campaign. We collected around 60 kilos of samples for our laboratory, plus other samples that have been collected from the NASA team. The measurements performed with the Vemulator were quite successful, and the LiDAR team collected so many good data that some members of our team were not sleeping in the night to download the data and to have the system empty and ready to take data the day after. Then we also got the coolest group picture ever, and I will show it to you just for fun. And we still have to work a lot on the data acquired and on the samples acquired, so much more yet has to come after the analysis of the data and the lab measurement. I will show you here. Okay, I will explain you how it works. So basically what we decided to do is to take a picture with the LiDAR systems. So we were all standing basically in the middle of the street around the structure that to us resembled Venus. So we then put the LiDAR system around us, and then we let the LiDAR took the data, and then a member of our team, Gael Cascioli, he generated this video using the LiDAR data. So you can see here all the team sitting around what we thought it was Venus. And the video goes around showing all of them. A fun fact about this video was that we were exactly standing in the middle of the street, and to take this picture, we had to stand there 5 minutes, just looking at the LiDAR and smiling, and while the cars were running around the street, thinking maybe these people are crazy. And that's it. Okay, that is enough. So we had also a great media campaign because there was NASA expedition that posted not all, but most of the adventures on the field. The NASA, the DLR team, a DLR media team came to Iceland and follow us on the field, and they published several articles, and also on Flickr you can find some really cool pictures of the campaign, and on Instagrams there have been posted many pictures during our campaign, and also NASA published different papers on that. So this is my last slide, another group picture of the field team during the last evening in Iceland.